The polar vortex is a large area of low pressure and cold air that surrounds both of Earth's poles. This phenomenon is a crucial component of our planet's climate system, playing a significant role in regulating temperatures across the globe. It is stronger in the winter when the temperature difference between the poles and the equator is at its greatest. During this time, the contrast in temperatures creates a more pronounced and powerful vortex, which can have far-reaching effects on weather patterns. The vortex typically spins counterclockwise, keeping the coldest air trapped in the Arctic. This counterclockwise motion is a result of the Coriolis effect, which influences the direction of wind and weather systems on Earth. This spinning mass of air is held in place by a balance of forces, including the Coriolis effect caused by Earth's rotation. The interplay of these forces ensures that the polar vortex remains a stable and persistent feature of the polar regions. The strength and position of the polar vortex can fluctuate, influencing weather patterns across the Northern Hemisphere. These fluctuations can lead to significant variations in temperature and precipitation, affecting everything from winter storms to heat waves. A strong polar vortex usually keeps cold air locked in the Arctic. When the vortex is stable and well-defined, it acts as a barrier, preventing the frigid air from spilling into lower latitudes. A weakened or disrupted polar vortex, however, can allow frigid Arctic air to escape and flow southward, leading to extreme cold outbreaks in lower latitudes. These disruptions can be caused by various factors, including sudden stratospheric warming events, which can weaken the vortex and cause it to split or shift. Sudden stratospheric warming events occur when the temperature in the stratosphere rises rapidly, disrupting the polar vortex. This can lead to a cascade of weather changes, resulting in severe winter weather in regions that are typically milder. Understanding the behavior of the polar vortex is essential for predicting and preparing for extreme weather events. By studying past occurrences and monitoring current conditions, scientists can provide valuable forecasts that help communities brace for potential impacts. Ongoing research and advancements in meteorological technology continue to improve our ability to predict changes in the polar vortex. This knowledge is crucial for mitigating the effects of extreme weather and protecting lives and property. The polar vortex is a powerful and dynamic force in our atmosphere, shaping the climate and weather patterns we experience. By deepening our understanding of this phenomenon, we can better navigate the challenges it presents and adapt to our ever-changing world. Strong stratospheric warming, as its name suggests, is characterized by a rapid increase in temperature in the stratosphere, the layer of the atmosphere above where we live. This phenomenon can disrupt the polar vortex, weakening it or even splitting it into multiple smaller vortices. This unusual warming in the stratosphere is often linked to disturbances in the flow of air masses, sometimes originating from the lower atmosphere called the troposphere. These disturbances can propagate upwards, disrupting the usual westerly winds that maintain the polar vortex. As the stratosphere warms, the pressure difference between the pole and lower latitudes decreases. This can weaken the polar vortex, making it more susceptible to disruption and displacement. The expected collapse of the polar vortex in March 2025 is causing concern among meteorologists due to its potential to significantly disrupt weather patterns across North America. With the polar vortex weakened, the likelihood of cold air outbreaks pushing deep into the United States and Canada increases. The eastern United States might experience periods of unusually cold temperatures and increased snowfall. Western Canada and parts of the western United States could see colder than average temperatures and potential for increased precipitation. The exact location and severity of these weather events remain uncertain, as the behavior of a disrupted polar vortex can be unpredictable. However, the potential for significant disruptions to normal weather patterns is high. One of the most concerning consequences of a weakened polar vortex is the increased risk of extreme cold air outbreaks. When the vortex is disrupted, frigid Arctic air can escape its usual confines and spill southward, bringing unusually cold temperatures to lower latitudes. These cold air outbreaks can be sudden and severe, leading to a rapid drop in temperatures. Such extreme cold can pose significant risks to human health, infrastructure, and agriculture. The potential for power outages, transportation disruptions, and increased energy demand highlights the need for preparedness in the face of a collapsing polar vortex and the cold air outbreaks it can bring. Section 5, Wind Reversal and Jet Stream Disruptions. In this section we will explore the intricate relationship between the polar vortex and the jet stream, and how their interactions can lead to significant weather changes. The polar vortex is closely linked to the jet stream, a band of strong winds high in the atmosphere that guides weather systems. This powerful current of air flows from west to east and plays a crucial role in determining our weather patterns. A strong polar vortex typically keeps the jet stream flowing in a relatively straight west-to-east pattern. This results in more stable and predictable weather conditions, with fewer extreme events. However, when the polar vortex weakens, the jet stream can become wavier and meander south, allowing cold air to plunge southward and warmer air to push northward. This waviness can cause significant shifts in weather patterns, leading to more variability and unpredictability. This disruption can lead to more extreme weather events and unpredictable swings in temperatures. For instance, regions that are typically mild may experience sudden cold snaps, while areas accustomed to cooler weather might face unexpected heat waves. These disruptions in the jet stream can also cause weather systems to stall, leading to prolonged periods of extreme cold, heat, drought, or precipitation. When weather systems stall, they can bring extended periods of heavy rain, resulting in floods or prolonged dry spells, leading to droughts. This can have significant impacts on agriculture, water resources, and ecosystems. Crops may suffer from unexpected frosts or heat waves, water reservoirs might experience fluctuating levels, and natural ecosystems could be stressed by the rapid changes in weather conditions. Understanding these dynamics is crucial for preparing and adapting to the challenges posed by a changing climate. Section 6. Preparing for the impacts. Given the potential for significant weather disruptions, it is crucial for individuals and communities to prepare for the impacts of a collapsing polar vortex. This includes ensuring homes are properly insulated, having emergency kits readily available, and staying informed about weather forecasts and warnings. Being prepared for potential power outages, transportation disruptions, and extreme cold is essential for minimizing the risks associated with this weather event. Section 7. Historical Context and Future Implications. The collapse of the polar vortex is not a new phenomenon, but the frequency and intensity of these events appear to be increasing. Historically, the polar vortex has been a stable and predictable feature of our planet's climate system. However, recent years have seen a marked change in its behavior, leading to more frequent and severe winter storms that impact large swaths of the Northern Hemisphere. While a single event cannot be definitively linked to climate change, the warming Arctic is thought to be playing a role in disrupting the polar vortex. The Arctic region is experiencing some of the most rapid changes due to global warming, with temperatures rising at twice the rate of the global average. This accelerated warming is causing significant reductions in sea ice and altering weather patterns. As the Arctic warms at a rate faster than the rest of the planet, the temperature difference between the equator and the poles decreases. This temperature gradient is a critical driver of atmospheric circulation patterns, including the jet stream, which in turn influences the stability of the polar vortex. This reduced temperature gradient is thought to weaken the polar vortex, making it more susceptible to disruptions. When the polar vortex weakens, it can lead to the jet stream becoming wavier, allowing cold Arctic air to spill southward into lower latitudes, resulting in extreme cold weather events in regions that are not typically accustomed to such conditions. Understanding the link between climate change and these events is crucial for improving our ability to predict and prepare for future disruptions to the polar vortex and their associated weather extremes. Scientists are working tirelessly to develop more accurate predictive models that can help us anticipate these changes and mitigate their impacts. This research is vital for informing public policy and ensuring that communities are better prepared to handle the challenges posed by an increasingly unstable climate system. Section 8. Conclusion: A call for preparedness. The expected collapse of the polar vortex in March 2025 serves as a stark reminder of the interconnectedness of Earth's climate system and the potential for significant weather disruptions. While the exact impacts remain uncertain, the potential for extreme cold, disrupted weather patterns, and cascading effects on various sectors underscores the importance of preparedness. By understanding the science behind these events, preparing for potential impacts, and addressing the underlying factors contributing to a changing climate, we can mitigate risks and build resilience in the face of an uncertain future.